All right, 7th graders, this is your FA 22. This is the test that you took last week, Friday, and we're going to make test corrections to it. So you're going to, on a sheet of binder paper, go over the problems with me, and you're going to take notes on all of them, not just the ones that you got wrong, but all of them. All right, here's the test. So let's start with mental math. Mental math, the problem said, what does a line look like if it is a positive slope? Okay, so we would have drawn a picture that shows a line with a positive slope going up and to the right. Now, B said, what is the slope of a horizontal line? So remember, horizontal lines look like this. It looks like the floor or the ceiling. What is the slope of a horizontal line? The slope is 0. So that would be the answer. C said, what does a line with a negative slope look like? So a line with a negative slope goes down and to the right. D said, if you have a vertical line, what is the slope? So here's a vertical line. Reminds me of a wall, and the slope of the wall is undefined. So the slope of a vertical line is undefined. E said, write the slope formula. And the slope formula would be m equals y2 minus y1 divided by x2 minus x1. F said, write the equation of a line in slope-intercept form. The equation of a line in slope-intercept form. So that's y equals mx plus b. G is if you have a horizontal line that passes through the y-axis at 2, what is the equation of your line? So let me repeat it. You have a horizontal line that's passing through the y-axis at 2. What is your equation of your line? So if here's my coordinate plane, and I have a horizontal line passing through at 2, it would look something like this. So what is the equation of that line? Well, that line's equation is y equals 2. Okay, the next one, H. H says if you have a vertical line passing through the x-axis at -5, what is the equation of your line? So let me repeat it. You have a vertical line passing through the x-axis at -5. So I'm just going to draw a little picture. 1, 2, 3, 4, 5. And so a vertical line runs like this, and it passes through that x-axis at -5. So what is the equation of the line? Well, this line is x equals -5. Okay, J was, if you have the equation of a line, y equals 2/3 x plus 7. What is your slope? Y equals 2/3 x plus 7. So if you have to, you can jot that down when I'm saying it. 2/3 x plus 7. What is the slope? The slope is that 2/3. So my equation, or my answer would be m equals 2/3. Now the last one, J, if you were given the equation y equals -6x plus 4. Y equals -6x plus 4. What is the y-intercept? Well, the y-intercept is when x is 0. And when x is 0, the y-intercept is -4, or the b of my equation is -4. Okay, so those were the mental math. Now let's take care of the part 1. Write an equation in slope-intercept form for each function. Okay, so number 1, if you needed help with this, you could have used scratch paper, you could have graphed it on this little coordinate plane, whatever you need to do. But remember, an equation in slope-intercept form is y equals mx plus b. So I need to know my slope and I need to know my b. Well, they actually gave us the b. The b is when x is 0, where does it cross? It crosses at 14. So my y-intercept is actually 14. Now, in order to find the slope, I have to use my slope formula, which, remember, we did up for e. Here it is. Okay, so using that formula, I solve for m. So I'm going to use these first 2 points, and I'm going to solve for my slope. So I'm going to say that this is my point 1 and this is my point 2. So I have 8 minus 5 over 2 minus 3. And 8 minus 5 is 3, and 2 minus 3 is negative 1. So my slope is negative 3 over 1. Okay, and so now if I write it in an equation of a line, I plug in my slope, which is that negative 3, and I plug in my b, or my y-intercept, which is 14. So those are the answers for number 1. Now, this next part of number 1, instead of giving you the list in a chart format, they gave you a line on a graph. And so if we take a look, we can see what these points are. This first point is 0, 3. And this second point is 1, 2, 3, 4, 5, 2. Okay, and we can tell that our line is going in a negative direction, which means my slope's going to be negative. So this time, instead of solving using slope formula, which I can because I have 2 points, I'm just going to count rise over run. Since they gave it to me and I can see it, I'm going to go ahead and count rise over run. So my rise is 1 and my run is 1, 2, 3, 4, 5. So my rise was 1 and my run was 5. So my slope is a negative 1/5. Now my y-intercept, where is it crossing the y-axis? It's crossing at 3. So again, remember the equation of your line is y equals mx plus b. So you have to plug in the m, which is the negative 1/5, and you have to plug in the 3 for the b. So y equals negative 1/5 x plus 3 is the equation of this line. Okay, we're going to move on. So let's take a look at number 2. Now number 2 says that Drew is starting a video club out of his garage. He charges his friends $3 to join the club and 50 cents to rent a video. Use the graph to plot a relationship of total cost on the y-axis and videos rented on the x-axis, and plot the ordered pair that represents the total cost of joining Drew Video Club and renting 6 videos. So if he rents 6 videos, he has to pay 50 cents each. So 6 times 50 cents is $3. But he also has to pay the joining the club fee, which is another $3. So that means when he rents 6 videos, his total cost is $6. So that's this point right here, 6, 6. And most of you got that point. Most of you put it on there. However, what you're forgetting is that this is a linear equation, and linear means line. So we have to turn that point into a line. Now think about what you know. If he rents 0 videos, way over here, 0 videos, how much does he owe? Well, he actually owes $3 just for joining the club. So we have that point, 0, 3. And now we have 2 points that we can connect with a line, and we've drawn a linear relationship. And again, the cost of renting the 6 videos we solved was $6. So this is the work that I was looking for. You had to have 2 points, okay? And if you didn't have the 0, 3, it would have been okay as long as you had another point. So you could have found out what it cost to rent 8 videos or what it cost to rent 2 videos and plotted that. But you needed a linear relationship, okay, which means a line. All right, let's take a look at number 3. So number 3 says, use the table to determine 3 sets of ordered pairs and graph the function. Okay, now if you don't like what they're doing here, you can make your own XY chart It's totally fine. In fact, that's what this column here is. It's the XY chart, okay? So what you're saying to yourself is, here's my equation that I'm dealing with. Y equals X, okay? Now think about it. The equation of a line is Y equals MX plus B. So if I'm dealing with this line, what is my slope? Well, my slope is the number sitting in front of the X, and that number is a 1. And what is my B? If I have nothing sitting there, what is my B? It's a 0. Okay, so that's what it means. So if I plug in the value of -2 for X, okay, which is what this column right here is. If I plug in -2, I'm saying, what do I get out for Y? Well, if Y equals X and I plug in a -2 right here, then what is Y? Y is -2. So this would be -2, -2. So try another one, or you could put it in your own chart over here. It doesn't matter which kind of a chart. Okay, so now we're saying, what if I plug in 0? What if I plugged in the 0? Let me change my color for a minute. Okay, so if I plug in 0 here, 0, 0, 0, what's Y? Well, Y is 0. So when X is 0, Y is 0, which makes the point 0, 0. Okay, same thing. If I plug in a +2, what do I get out? I get out a +2. Well, now we have 3 points that we can use to graph. And you could have used any numbers. It doesn't matter what numbers you used. So I have the point -2, -2, which is here. And I have the point 0, 0, which is here. And I have the point 2, 2, which is here. And I can see that it makes a nice straight line. It's a linear function. And there it is. Okay. All right, let's move on to our next slide. Okay, so this is our next slide, and this is problem number 4 of your test. Determine the slope of each linear function. So we have lots of ways to determine slope. We can either count rise over run, or we can use our slope formula. So I'm going to do it both ways. First, I'm going to count rise over run. So I'm going to choose these 2 points right here, and I'm going to figure out what their rise over their run is. So I can see that my line is going negative. So if I count this slope, it's got to be a negative. And it rises 1, 2, 3. So it rose 3 and it ran 1. Okay, now let's check 2 different points. Let's check these 2 points. Okay, and let's check the rise over run. It rises 1, 2, 3, 4, 5, 6. And it's still in a negative direction. And it runs 1, 2. So that reduces to -3 over 1. So it doesn't matter which 2 points I use, I still get the same slope, -3 over 1. Or you could just write -3. It doesn't matter which way you write it. Now, if you wanted to use the slope formula, you could, hang on, let me erase my circles so that we can see this graph again really clear. Okay, so I want to just name these points. Well, this first point is 0, -1. And the second point is +1, -4. And I can use those to solve using my slope formula. y2 minus y1 over x2 minus x1. That gives me, if I call this guy right here my point 2, then I'm going to say -1 minus -4 over 0 minus 1. And so this is really a plus a positive. So I end up with 3 over -1, which is what I said my slope was. So no matter which way I did it, I got the same slope, -3. Okay, now we're going to do the next problem, number 5, and determine the slope. We're going to use our formula. y2 minus y1 over x2 minus x1. So I'm going to call this my point 1 and this my point 2. So I have a -2 minus a 1 over a -1 minus a 3. And so I can change these to adding the opposite to help me. And I end up with -2 plus a -1, which is a -3. And a negative 1 plus a negative 3 is a negative 4. And a negative divided by a negative is really a positive. So my slope is really 3/4, and it's positive. Okay. Now let's take a look at our last problem. Distance. Jason rode his bike at 19 miles per hour for 3 hours. So if he went for 1 hour, he rode 19 miles. If he went for 2 miles, what did he run? Or what did he ride? He rode 38 miles. Okay, if he went for 3 hours, how long did he do it? Well, 19 times 3 gives me 57. So for 3 hours, he went 57 miles. But then he did something else. Then he rode 22 miles an hour for 2 hours. So for 1 hour, he did 22 miles. And for that second hour, he got up to 44 miles. It says, how far did he travel altogether? So we're going to take our 57 and we're going to add it to our 44. And we're going to say that in the 5 hours that he rode his bike, he went 101 miles. And we're going to box our answer. Okay? And now let's move up and do our CST problem. Our CST problem says, according to the graph, how much will 5 pounds of bananas cost? Well, pounds is down here, and cost is over here. So 5 pounds is here. So I'm just going to kind of draw my little line up and see where it touches. Okay, it crosses right about there. And I'm going to take that point and I'm going to go over. Whoops, I didn't do that so well. Whoops, still didn't do it so well. Let's try again. It touched here and it went over about there. Okay, so when you look at that, what are my possible answers? Can it be 250? No, really far off. How about 350? No, kind of far off. Now, 450 and 550 could be close, but look, you can tell it's under $5. So that's when you can say, oh, must be 450. Because you can use common sense and say, no, 550 would be way up here, and it didn't cross there. So it must have been 450. So my answer for this one is C. Okay, that's it for today for the test corrections. Make sure you do your regular homework as well. These corrections are due on Thursday.